And I'm going to remind you of a couple of things. First one is there's a quiz tomorrow. What is the quiz on? Moles and grams and particles. Yes? Okay. And I am going to give you a little mole summary sheet today. I just need to hole punch them for you. Okay, and then I need to make sure I've got enough for the hole punch. You actually have this on page 3, so if you don't want to wait for it, you can turn to page 3. But this one is nice and purple and easy to find. One, two.
It still says hi to again. Yeah. Yeah, Matthew's probably. I was gonna stay. We didn't watch this game. My dad forced me to go. He's I could have watched this live. I could have watched it after. But no, dad wasn't.
Wow, your dad really has the priorities out of whack. Holy moly.
This semifinal is crazy. It's not one of this movie. There's 6 goals haven't scored.
Okay. Now. Yeah.
You see it all over. If the top of the box hits against the side, I have no idea. Who doesn't have one?
Sorry about that. I miscounted. There you go. First of all, what is the quiz on tomorrow? 5.1 and 5.2. Okay. So we have a quiz tomorrow on 5.1 and 5.2. Okay. I guarantee you there is going to be one question that includes a diatomic element. And if you forget which ones those are, you can remember Dr. Brinkelhoff, okay? Or you can remember if you start on element 7, which is nitrogen, and you draw a 7, right? And then you go, oh, but that's only 6. So the other one, the 7th one, is hydrogen. And then you have your hockey stick and your puck. Okay? Or if you don't like either of those, you can remember have no fear of ice, cold, beer. Okay, hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Okay, I like Brinkelhoff, but I also like the 7. 7's easy, just look at it, right? And the questions that I suggested that people do to like make sure you have like full conversion all the way, 4 steps going one way, 4 steps going the other way, are 9, 10, 11, and 13 on pages 52 and 53. If you have not done those already, make sure you have tried those, because that's going to be like, at least one question on there will be like the full meal deal all the way across. Now, we have here What? Here we are. So the conversion factors that you are responsible for tomorrow are on this purple sheet. And you are responsible for molar mass, which allows you to go between grams and moles. You are responsible for Avogadro's number, which allows you to go from moles of A to particles of A. You are responsible for the particle ratio, which allows you to go from particles of A to particles of B. Okay? Now, from moles of A, if you don't want to go straight to particles, you can actually take moles of A, and instead of going to particles of A, you could go to moles of B. Yes? So very often there are two pathways in a question. You can use either the particle ratio or you can use the mole ratio, and both of them are correct. Okay? If you want to use this sheet on your quiz, I'm not going to stop you, but it will cost you 10%. Okay? So if you're okay with a maximum of 90, if you're like, I really don't know what I'm doing and I just want to have this sheet, and it would be lovely if I just had that sheet. And on the other side, you'll notice that it gives you things like it tells you there's 6.02 times 10 to the 23 atoms per 1 mole of atoms and things like that. If you're feeling like, I need that, that's okay. You're just not there yet. You'll get there, but you're not there yet. You can use it, but for a 10% price. Okay? Today, we're going to learn something a little bit new, and then you are going to practice for the quiz tomorrow. So the something new is 5.3a, which is on page 55. So let's remind ourselves, what is a solution made of? Solute and solvent. And what is another word for solution? Homogeneous mixture. Okay? And the substance that is present in the smaller amount is the solute, and the substance that is present in the larger amount is the solvent. The most common type of solution in chemistry is a liquid solution. What is our liquid that we would normally involve in this solution? Celia, why are you on your phone? Water. Okay? And usually we dissolve something in the water. What do we call a solution where water is the solvent? We call it a what kind of solution? An aqueous solution, okay? So aqueous solution is where water is the solvent, and we can represent that by writing the little AQ down at the bottom. Now, today we are going to be talking about concentration. How many people feel that they understand what the word concentration means? Okay, about half of you. So let's just talk about concentration in general for a moment. Let's draw ourselves a couple of beakers. Okay. Got some water in there. That's beaker A. I drew it in an X. I didn't mean to do that. That's okay. Which solution is more concentrated? More concentrated? And this one is less concentrated. And if it is more concentrated, that means there is more what? solute per volume of and this is where I want you to pay close attention to this, is not per volume of solvent, it's per volume of solution. Okay? And that's going to become important in just a wee bit. All right? So that's what we mean when we say concentration. How much solute is there in a given volume of solution? When we say how much solute, what kind of unit could we use to measure how much solute? Think about that. Talk with your partner. What unit could measure how much solute? Unit could be grams. What else could it be? Milligrams. And if you know grams, what else could you find? You could find moles. Okay, so it could be grams, it could be milligrams, it could be moles. We could use molecules, but that seems like a lot of effort. I think writing all those 10 to the 23s and stuff, okay? So that is how much solute, and it is the amount of solute in a given volume of solution. What is the unit of volume? What is a volume unit? Tell your partner, what is a unit of volume? Centimeters cubed is one. Can you think of something that is equal to a centimeter cubed? 1 milliliter. What else? Liters. Okay, those are your big ones. I mean, you could do cc's, which is just cubic centimeters done a different way. In medicine, they call it a cc. All right, but those are the big ones. All right, so your concentration is how much solute there is in a given volume. So that's going to be either grams per liter, or milligrams per liter, or milligrams per milliliter, or this is our default concentration, moles per liter. This one gets a star because that is the default unit of concentration. I'm either going to abbreviate concentration as conc or as concentration with a little n up at the top. Okay? Default unit of concentration. And you remember I said it was concentration is measured as the quantity of solute over the volume of the solution. It is not the quantity of solute over the solvent, volume of solvent. Okay? And we're going to find out why very, very soon. So let's, for example, say that we have this container in which we are going to make a solution. I just made it last block, so I have to empty it out. Okay. I have some salt. Okay, just plain old NaCl. And I want to get it into here. And I have, where did I put my other funnel? I have two different funnels. Which funnel will be better for transferring salt into a flask? The skinny one or the fat one? Why is the fat one better? Salt is bigger. It's a solid, right? And it might get stuck in the liquid funnel. So let's take a look at our little picture here. Probably on Friday, we're going to actually make a solution. Tomorrow we won't have time because we have the quiz. All right. But we'll do it on Friday. So what you're going to do is you're going to say, I would like to have 1 mole of NaCl. So I start up here with 1 mole of NaCl. How am I going to make sure, like if I wanted to go and get 1 mole of NaCl from here, how would I make sure that I got 1 mole? Yes?
You would weigh it?
I would weigh it. Yeah? And how would I know how much to weigh to get 1 mole? I would go to the periodic table because I would just need its molar mass. Okay? And they've done the calculation for us here. I guess their periodic table goes to 2 decimal places with the masses they've calculated. I would need 58.44 grams. Well, I'm not going to use a mole. I'm just going to use a couple of scoops because I don't actually care what the real concentration is. I just want to show you how to do it. And I am not going to use, how big of a flask is this? Look at the picture. You can look in your book if you can't read it. What size flask is this? It's super easy. It's literally in the middle of the page. 1 liter. It is a 1 liter flask. So on here, there is a line etched into the glass, and that marks where 1 liter of volume is. Okay? So if I fill that with water up to there, then I have 1 liter of water. Yes? Okay. I'm going to downsize a little bit because I don't want to be wasting a liter of water. So I'm going to use this one. This one is 100 milliliters. And it has a line on it, which is right here. Okay, I'm going to put my finger beside it, but you can also probably see the line. Can you see the line? That line there, where my finger is the 100 milliliter line. Okay? Now, I'm going to put some of the solvent into the flask. Okay, so there it's going to go into the flask. And the name of that funnel, and you should know its name, that kind of funnel, that thick funnel, is called a powder funnel. Okay, I guarantee you there is going to be a question, not on tomorrow's quiz. None of this is on tomorrow's quiz. None of this is on tomorrow's quiz. But your next quiz, there will be a question saying, how would you prepare? What does prepare mean? Make. Okay, prepare means make. I got all kinds of people asking me about prepare, and I don't know. It means make. How would you make a solution of 250 milliliters of 0.6 molar barium carbonate or something like that, okay? And what you would need to do is do the calculations, but then you would also need to say, I need a powder funnel because I'm going to use it to place into the, and I haven't told you the name of this flask yet, so let's name that. This right here is a volumetric flask. It's called volumetric because it measures one specific volume. Okay? This one measures 1 liter volume. This one measures 100 milliliters volume. Oh, because then it makes it really hard to mix. You do need some airspace so you can mix it. Okay? So there's our marker. All right? Now, because we're a high school, we don't get the equipment we necessarily need, the perfect equipment. Watch this. Too big. Yes? However, if we use this one, your solute's probably going to get stuck. So what you're going to do is when you do this on Friday, you're going to hold it on there just like that, and it'll work. Okay? You just hold it. Yes? Never would this happen in the private sector. Although actually that's not true. If your private sector business is not doing so well, this could happen, okay? So there we are. Now, I'm not measuring out a specific amount, so I'm just going to dump some in, okay? La, 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 la. All right, I now have some solute, yes? What did this line measure? 100 milliliters. This is a 100 milliliter graduated cylinder. I'm going to fill it with 100 milliliters of water. Here we go. La, 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 la. Did I get it close? So close. There we go. Okay. All right. I want to make 100 milliliters of solution. So I took my salt, and now I'm going to add 100 milliliters of water. Do we feel happy about this? Will this make me 100 milliliters of solution? Tell your partner what you think's going to happen when I put this in here. I'm going to put all 100 milliliters in.
I don't think that's, yeah. I think it's Is it one more salt?
I don't know how much salt there is. There's like 3 scoops of salt. Okay? Shall we watch? Shall we see? Okay. And remember, there's our 100 milliliter line. Okay, are we ready? Did you have something you want to? No, you're good? Okay, here we go. Oh, and before we fill it all the way, if I fill it all the way, it's going to be hard to stir. Yes? I want to have a nice open space up here so I can do this. Yes? I want to be able to swirl it in order to mix it. All right? And I'm going to swirl vigorously, and I'm going to swirl in both directions because you get better mixing if you get randomized motion. So I switch directions every once in a while just so it doesn't all move the same direction. And this could take forever. So I'm going to pretend that this is all dissolved. Yes? It's not quite all dissolved, but we could be here for a while if I spent all that time. Now, I'm going to finish adding the 100 milliliters of water. Ah! So I added 100 milliliters of water, and it filled it all the way to the top, and then it overflowed. Why? The salt gets bigger. Okay, let's think about it. There was 100 milliliters of water. That's the 100 milliliter line. What's making up that extra volume? The salt. So, don't tell me if I want to make a 100 milliliter solution that I need 100 milliliters of water, because I don't. If I have 100 milliliters of water, I will make more than 100 milliliters of solution, and I won't know what the volume is because I don't know the volume of the salt. Salt is difficult to find a volume of, yes? So we always just measure the volume of solution, and the way we do that, let me get rid of this, is that we add our solute, and I'm not going to add very much this time because I don't want to spend too much time dissolving it, but I add my solute, here we go. And then, how far do I fill it with water? Where do I fill it with water? Do I fill it up to the line?
Okay.
Or do I fill it up to the top? Or do I fill it up halfway? Halfway, because I still need to swirl it, okay? So before you fill to the line, you have to fill it about halfway, okay? Swirl. Okay, we're going to pretend that's all dissolved. And now I'm going to add more water, until I get to the line. Now, if I was being really careful, I wouldn't just be pouring it. Once I got close to the end, I would actually use an eyedropper. Do you guys know what an eyedropper is?
Yeah.
It's like a little medicine dropper. You go drip, 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 drip. If you don't know what one is, you'll be using one on Friday. Don't worry. I'm just going to pour because I don't want to take the time to go find one today. Okay, I went past the line a little bit. If you go past the line, you have to start over again. So I would have to start over. That's why you use the little dripper at the final step. But let's pretend that I did not go over. Huh? Okay, so over means I've gone over the line. Okay, so I have a little bit more, but let's just pretend this was at the line. At the bottom, I had salty water, salt water. Salt water. And then to the top, I added fresh water. Is this going to be, will this top part taste as salty as the bottom part? No. These two things won't mix completely until you mix them, because salt water is more dense than fresh water. It's going to stay at the bottom unless you physically mix it. You might be able to get it to diffuse over time, but you might have to wait like a couple of weeks. Do you want to wait a couple of weeks? Oh. So in order to do the final mix on this, to make sure the concentration is even, you are going to put a stopper on the flask. And then I'm going to teach you a word, because last year I had so many students tell me to flip the flask. Do you want me to flip the flask? Does that sound like a good idea? Flipping? Flip the flask. Do you want me to flip the flask? Flipping? Yes.
I think we should invert the flask.
We should invert the flask. That is the new word, invert. You can say you should turn it upside down and right side up, and upside down and right side up. That's a lot of words. Yes? But if you learn the word invert, that means turn upside down. So here's how we go. Step number 1. Add 1 mole through the powder funnel into the volumetric flask. Okay? You are going to add some water. How much? How full? Are we going to fill it to the line? No, we are going to fill it to halfway. Halfway. So 1, 2, 3, 4. You're going to fill it halfway. And then what do you do with it once it's filled halfway? You're going to swirl to dissolve. That's step 5. Okay? Step 6, what do you do after it's all dissolved? Add more water to the mark. Add water to the mark. Technically, it's called the calibration mark, but you can just call it the mark. Okay, and everyone will know what you're talking about. So that's 6. And then are you done? No. Step 7 is to put in a, what did we call this? It stops the water from getting out. It is called a stopper. Okay, it stops the water from getting out. It is called a stopper. Yeah, I'm going to write that out. Okay, so we're going to step 7. Stopper the flask. S-T-O-P-P-E-R. And then 8, invert, this vocab word, to mix. If you want to say turn it right side up and upside down and right side up and whatever, feel free. But don't tell me to flip the flask. Nobody wants flipping flasks. No flipping flasks. Got it? And that's it. Okay, that's how you make a solution. All right? Now, how you don't make a solution, if you recall, you don't add 1 liter of water to make 1 liter of solution, right? 1 liter of water will give you more than 1 liter of solution. Is good? Okay. A little bit more to learn today. Next page, 56. Now, I remember I said the default unit is moles per liter. That's our default unit. When we use moles per liter, we can actually describe that, and I forgot to mention this to the other block, we can call that the molarity. What's the molarity? If I say, what's the molarity, I mean, how many moles per liter are there? If I say, what's the molar concentration? That means, how many moles per liter are there? This is page 56. Isn't it? Yes, it is. 56. Right at the top. Okay? Moles per liter. So the molarity is the moles per liter. And the molar concentration is the moles per liter. And that's moles of solute per liter of solution. All right? There are 3 different ways you can write moles per liter. You can write out the entire word, moles per liter. Or you can write moles per liter, or you can write capital M. And that is the short version. Okay? I don't know if you guys, are you familiar with the unit joules? Yeah? Okay. If you were to actually write out joules in SI base units, it would be a kilogram, don't have to write this down, kilogram meter squared per second squared. But do we always want to be saying, oh, this thing has an energy of 10 kilogram meter squared per second squared? That sounds crazy. Yes? We want to say this thing has an energy of 10 joules. Yeah? So we often will take a unit and then simplify it into just one thing, like a compound unit, and simplify it. And that's what we're doing here. Now, this capital M, we don't say M, we don't say moles per liter. This thing is pronounced molar. Okay? So I could have a solution that is 1.0 moles per liter. And I would write that as 1.0 moles per liter. Or I could have a solution where I say it is 1.0 molar. And I would write that as 1.0 molar. And these two things are the same. 1.0 moles per liter and 1 molar are the same. Is good? Okay. So, how do we calculate this? There's a couple of ways of calculating it. You can use a lowercase c to represent concentration. I put that little tail on it so that it looks like a lowercase c because it's not a capital C. And that makes sense to me because I learned cursive, and that's a cursive C. Yeah? You just have to write a small c and hope it doesn't look like a big C. Or you can write a cursive C. I would actually advise that you do none of that. I would advise you use the other way of writing concentration. So if we wanted to write concentration of NaCl, we would write concentration of, and then subscript NaCl. Okay, that means concentration of sodium chloride. You will see that in some books. That's one of the reasons I show you. If you like to write it that way, I'm not going to stop you. Okay? There is a different way to write concentration of NaCl, and that is to put square brackets around it. That right there means concentration of NaCl in moles per liter. Not grams per liter. Specifically, if you write those concentrations like that, brackets like that, that means in moles per liter. Why am I harping on about this? Because I get students in grade 12 who can't remember this. So hopefully you'll remember it. Yes? This is way easier to type. So that's why I use it. One of the reasons why I use it more often than the other one is because it's really hard to subscript. You have to like control plus, control minus, and then heaven help you if you want the concentration of H2SO4, you have to subscript within your subscript. And then you have to go into like control font, and then you have to change it. You have to like go, oh, what is it? You know, position, alt position, raised, lowered. It's a nightmare. So much easier just to say concentration of H2SO4. Yes? Square brackets. How do we calculate this? Well, you can use this formula, C equals N over V, where C is the concentration, N is the number of moles, N is just moles, and V is the volume. So you can use that as a formula if you like it. Or you can use the following. You can say concentration of whatever it is that you want to find equals moles of whatever you want to find over liters. What I don't want to see is HCl molarity is moles over liters. That shows you don't know any of the two ways of writing concentration of HCl. Yes? We don't write concentration of HCl by saying HCl molarity. We don't do that. Concentration of HCl equals moles of HCl per liter. And then you could plug in your numbers. Yes? Okay. Now, volume always has to be in liters. So let's say I gave you 360.0 milliliters. How many liters is that? How would you do that? There's a few ways of doing it, okay? If you want to go way back and you want to do it like old style, you're going to be like mega, kilo, deci, centi, milli, micro, nano, and we got milli, which is 10 to the negative 3. Milli is 10 to the negative 3. So you can say, okay, I have 360 milliliters times, I want to cancel the milliliters and find the liters. Where does the 10 to the negative 3 go? Ten to the negative 3 goes with the milliliter or with the liter? It goes with the liter because what goes with the prefix? The 1 goes with the prefix. We do that and we would get 0.3600 liters. Now, that takes more time than I would like to spend. Yes? You should get familiar with the fact that if you take your milliliters and you, what do you do, Lasya?
How would 360 times?
Oh, negative 3, sorry. Negative, thank you. But Lasya, how did you do it? You divide by 1,000. And we do this so frequently, you should be like, okay, milliliters, I divide by 1,000. And when I divide by 1,000, how many places do I move my decimal? 3 places. So what I'm going to do is I'm going to take my 360 milliliters and I move my decimal place. Three places because we divide by 1,000. And I like to call this the boop, boop, boop method because we go boop, boop, boop. Yes, boop, boop, boop. Boop, boop, boop. Or bing, 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 if you prefer it. Do you like bing, bing, bang, bang, or boop, boop, boop? I don't care. What do you guys like? Bing, 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 boop, boop, boop. Which one? Boop, boop, boop is good? Okay, we go boop, boop, boop. And then here's our decimal over here now. So that's now going to be 0.3600 liters. Yes? Now if I had 22 milliliters, let's say, 22 milliliters. I take my decimal and I go, what do? Boop, boop, boop. 1, 2, 3, boop, boop, boop. 0 goes there, and I end up with 0.022 liters. Yes? So that's going to be an easy way to do it. If you want to do this whole thing, you can do this whole thing. It's fine. Whatever is easier for you. Okay? Let's try one question, and then I'm going to give you some time to practice for next day's quiz. All right, let's take this question here, and I wonder if it's still in my paste. Control V. Okay, here we go. We have this is on your next page, 0.25 moles of Li2CO3 are dissolved in enough water to make 460 milliliters of solution. So we have 460 milliliters of solution. Find square brackets around Li2CO3. What does that mean? Concentration of Li2CO3 in what unit? Moles over liters or molar, okay? So you need to write concentration Li2CO3. This is worth 0.5 marks. Don't leave it out. Equals. And then I would say that's moles of Li2CO3 per liter. Then we're going to plug in our actual numbers. We have 0.25 moles Li2CO3 per, am I going to put it over 460.0 milliliters? No. What do I have to do first? Boop, boop, boop. Boop, boop, boop. Boop, boop, boop. Boop, boop, boop. Move your decimal place 3 places so that it is in liters instead. So now we have 0.4600 liters. We do our division and we get, there's my calculator, 0.25 divided by 0.46 equals 0.5435. Now, do I want to leave my number like that, or should I round it to a certain number of sig figs? How many sig figs? 2. 0.54, and you can either write it as moles over liters, or you can write it as 0.54. And how would we say that? 0.54 molar. Okay, and that's where we're going to leave it for today because I want you to have some time to practice for your quiz. And that was page 53, number 9, 10, 11, 13, 52 to 53, 52 to 53.
Just for the next one.
Thank you.
What if you could just quiz right now?
What?
Never mind. Actually,
You're good?
I was gonna do the quiz today, but I
I want to. I got it. Okay.
So there's
Okay,
it's
good.
actually we could use like up to like over buckets today.
Yes.
So we wanted to make this oh I missed it.
Yes.
Wait. What?
We're pouring water on this people and just by today.
Wait. Oh yeah, I know. So today you didn't agree for today.
No, he did. We asked them. He asked
Wait.
why.
Yeah.
Like right before this class. And
I thought so. You said tomorrow.
oh, I guess he left.
No, he said yes. They do tomorrow.
Oh.
Mr. Coy is in here. They don't. Do you guys have? Wait. I was just gonna go downstairs to the bucket. I don't know. I was gonna go find somewhere. The red one? I think the red one is like big enough.
I mean, if we took out some second.
Yeah.
So I get the second.
There's 4 points.
Oh my god. And then just start giving the kids on the answer. Well, then questions like this. Like, if you just walk over to a hall,
Exactly. I mean, last year, you just had an entire presentation.
as a project where, right,
I had a friend who could do that. I had a friend who could do that. He's like just half-ass everything.
Well,
Back to Korea.
maybe the started after I was 6. So I didn't know anything about her and this time it's time to spend for
Oh, you should be like. Yeah.
Well, oh.
Oh.
I saw that. So tell us what happened. So she was like, well, guess what you're good now. I told you about her.
You feel better. That's fine.
It's like, I can move.
Yeah.
No, I saw this reel. I was we're just like my house for me crazy much. You know, bike marks loving a pride.
Yeah.
So you can find it.
Oh, that's true. I saw that. Yeah, now, can you go from round to number five? I was so.
He does have the text.
What?
First, you have to go around to the walls, and then you can go.
Well, why are you getting so stinky?
Rounds.
What are they?
Rounds only changes walls.
I can up here some iron bells. Probably our worst.
And
My favorite character is some merch.
I just feel it's got both lines.
That looks ahead of the same page.
I haven't even read it, and I just feel
My favorite character is Stop Bird.
I look at like direct lines on middle school.
okay.
What? Stop! I'm spoiling it. This is like the most important.
This is die of fucking lawyer.
Now, there's not. Now. Okay. But it was the road crew. Also, we divided that.
Nice section.
Now you're here. Where are you at? Yes. I don't find it great. Oh, you look at the top, you don't like that. How did you see Kate? How did you see Kate? Guys, you don't know, it's just so, oh my God. Oh, yeah. Is that right? So let's be a little bit more specific. Yeah. No, I don't see this. I guess. Yes. Yes. We'll go around the classroom. And you're in the right position. Yes. Some pages and so like pages.
What would be your stuff?
Oh, no.
Yeah.
Yeah.
Your roast was better than that. That's how it works.
I want to see that. So I got 65,
Yes.
but it should be 60.
Okay. And that's because we have one sig fig there. Oh. Yes.
All right, so this. Let's say we are. Absolutely. So I need to add this. Molecules.
I was big.
His pump is so you see that's what it says. His father's going to pay someone else to kill his own son. That's insane. What is that? Jackal's stuff. He's like, she's talking to
I have, when I started here,
He's insane. That's
I
what
wanna
he's
find the number of, yes.
No, it's yeah,
Let's
it's
start
you know.
That's the
This is the best.
Yeah.
Thing we can.
Yeah.
It's the best one.
Adam's got to cancel.
Oh,
You can take any of these commercial properties and turn them upside down. Okay, so just because it's written this way doesn't mean you can't flip it upside down.
so I can just.
Yeah, so you put Adam's down there and then it goes on top. Almost, yeah. Yeah. Yeah.
Then I think we was just together.
Yeah.
Oh, yeah.
There you go. Yes.
And I just leave that. How many six anything they.
3 seconds here, 3 seconds there. That's right.
Yeah.
Yeah.
Okay.
Yeah. Okay, cool.
But I found I when I send it to you.
That's what I do. It's work. It's work.
Yeah,
It's better for you to use it than not.
Yeah.
Yeah.
So it was kind of.
You could finish the Molarity.
Hello. That's what it's in. Yes. So we don't have that many grams of chloride, you want that many grams of CO2. And then you're finding, see, there's another step in which you're going from particle data, particle three, that, and, yeah.
Well, after using the. No, good. No, it's only like now there's something for the library book. Oh, it's very good. Like some of the proper these three all started creating on the page ahead of me, so it's what the best.
My jacket.
First one.
Red rice and total, I'm not. Perfect. I'm always looking for those three. Yeah.
They do like regular swimming pool?
There's a lot.
People all do that. There's a yeah, you can, but there's a fun way.
I thought that's right.
It sounds pretty light. I don't want to take it my knees.
Good.
For what? Don't take it from God, this is yours. What do you do this? You didn't get it. I checked it.
Can you still see like the sun's?
Like, that's my son. But yesterday, we got everything right, except we did something wrong on the whole Not gonna say that's wrong. No, everything we did yesterday was together, and it's right, I'm positive. Anything you did on your own, you might be wrong.
Yes, it does.
Well, I can show you everything yesterday. Go check, I know that we're gonna check.
Sunscreen needs active. And work effectively, it's recommended to apply sunscreen at least 15-20 minutes before sun exposure.
That is liberal communication.
It's in my car still, because I keep forgetting to bring it in.
Okay.
No, I don't.
So you have one there and that's it? Yeah, did you do it at the same time? It's gonna be so fun.
So basically, there. Actually, you can figure out that. Got it. You can help.
Oh, you have
But
wait.
I have, let's see, 1, 2, 3, 4, 5,
We
plus
need-
the one in my car.
We need three.
You need
Maybe
3?
use the red one.
What red one?
Yeah.
No, you cannot use the pink one.
Three is enough.
All is, I don't know what teacher put them away like this, but that pisses me off. When you bring them back,
Yep.
you dry them off,
Okay.
okay, and you
Okay.
put them on the side counter somewhere. Okay?
Or something like that? Okay.
Yeah, and this room will be open.
Okay.
Okay?
Alright, you guys go without me. You guys have no bucket, so I'll keep the bucket.
What?
Yeah.
Evan, he's gonna touch you. He's holding our bucket hostage.
Wow, that's so we just stay with them.
I'll test him. This guy is not.
I'm not.
Who would win? No fear of the
I would win. You know why?
It's Eric.
No. You guys come to me. And fight.
I'm not.
Oh, wait, what?
You have a free off?
Who's for free?
You know, or
Eric? I think I should be that. I touched you last.
Why are you
I feel like-
scared? I swear. I'm the only one
Oh, good today.
Eric's gonna be with Mr. H never
See any bring
combination.
It is like not just.
I'd say yes. They were okay. You can get taller fast.
Wait, guys. You guys need ice with this?
Oh yeah, we might die.
They said yes.
Here.
Yeah.
You have ice too?
Yep. We got everything.
What?
We got everything.
I was gonna get it from downstairs. It's full. What? Okay.
Okay?
Okay. I don't know how. I don't know if I should be glad about this or not. You want to do this?
Oh yeah.
One procedure.
Direction and.
You want to go nuts?
Just keep it for.
I know, but if you just break it, it's gonna be hard. I know. Yeah. I do feel like
We split up.
even.
Let's just split up.
It's fucking When?
Oh my god.
It's ain't no way. Hey, there's no.
Thank you so much for failing.
No, I did it already. I know, actually,
No. What's that?
It was 300.
Yeah.
You didn't give us
Alright, give me some. So yeah. Like that little What? What the fuck? Oh, hey. Oh,
onward. Just move. That's not
Each drop one. Let's go.
Well, I cross some fingers that it gets swept up there, but you know what?
And hopefully the generators will soon enough. And I'll get them. Oh, yeah. Thank you. Yes. Yeah. So you now. Because. Adam. Is this.
Yeah.
But what you have right now. Is this. A molecule. Yeah? Yes. That makes sense? Yeah. Okay, cool. Cool.